All right, this lesson is Chapter 1, Section 1 on functions and models. What is a function? For a set of ordered pairs, a relation is when the first coordinate is never repeated. In a function, there's only one output for each input. So each element of the domain is mapped exactly to one element in the range. So here is a mapping diagram where each value of the domain has one range. So you'll see here is 2, and it maps to A, B, and C. And we have our ordered pairs, and we go input to output, domain, and range. And these are how we list those ordered pairs. 2 maps to A, 2 maps to B, 2 maps to C. We can say a function as a relationship between two variables can be defined numerically, graphically, verbally, or can be described as an equation. Functions can be applied to help us to solve problems in the real world. So you'll see a lot of application problems in our course. Example 1, real life examples of relations that are functions. Example A, the temperature of a city based on the time of day. So we have a 2-column chart. We have the independent variable x, which is going to be the time. We have the dependent variable y, which is going to be the temperature. And we want to list out some appropriate domain values. So something like this. So at 6 a.m., the temperature will be 15 degrees Celsius. So that will be the temperature, the y. Then 3 hours later, at 9 a.m., the temperature rises 18 degrees Celsius. Then at 12 p.m., 3 hours later, the temperature rises to 23 degrees Celsius. So in this case, for each input, so these are all the inputs, there's exactly one output. All right, B, the cost of a taxi ride based off the distance traveled. So we could say at 2 kilometers, the cost of the ride is $5. When we go 5 kilometers, the cost of a taxi ride is $11. When we go 10 kilometers, the cost is $21. Again, the same is happening. One input to one output. So the same is happening here. So these are both considered functions. They are real life examples of functions. So one input and one output. Example 2. These are going to be examples that are not functions. A student's grade and their favorite color. So we have student A that gets a grade of a A. We have a student that gets a grade of a B, and another student that gets a grade of a C. And then they have a favorite color of red, blue, and then, uh-oh, we have red again. So here's the problem. Student A is red and student C is red. This is the issue. Both of these students have the same repeat. So student 1 and student 3 both like red. And that's what's going to cause this not to be a function. All right. The next scenario, a person's height and their shoe size. So we have one student that might be 5'8" in our class, and then we have another student that's 6 feet tall. We have another student who might be 6 foot 2 inches, and then we measure their shoe size, a size 9, a size 10, and a 10. And then again, we look at these two shoe sizes, they are the same. Even though their heights are different, it's the shoe size, the dependent variable. When the dependent variable is the same, that's what causes the issue. Both person 2 and 3 have the same shoe size. And that's why these are not a function. All right. Now we have some graphs. Example A is considered a discrete function. Why it's discrete is because the points do not connect. And this is not going to be a function. Why it's not a function, one way is you can tell by what we call a vertical line test. If we run a vertical line through here or a vertical line through here, it's what we call, it fails the vertical line test. Fails the vertical line test. It hits more than once. Then we ask you to list the ordered pairs. So we have the ordered pair 0, -2, 1, -1, 1, 2. Sorry, these are kind of getting messy here. 2, 0, and then 2, 1. The domain is going to be all your x values, 0, 1, and 2. The range will be all your y values, -2, -1, 0, 1, and 2. Now, what is f of 0? So we go to 0 on the x-axis. So here's 0, and we go down and find out what is the y. So the y is -2. The second one is saying, what is f of 2? So f of 2, so we go to 2 on the y. Here it is. And what are those y values? So here are the y, and they are, so f of 2, and there's 2 of them, 0, and 1. All right, the second example, is this a relation? Yes. It passes the vertical line test. If we create all these vertical lines, it touches one time every single time. I'm just going to erase those, but yes, it passes the vertical line test. Is it discrete or continuous? It's continuous because all of these points touch. They connect. The domain is going to be your x values. So the domain starts at negative infinity way over here and stops at positive infinity. So it's negative infinity to positive infinity. The range is your y values. So here's where it starts down here. This is your top and this is your bottom. Where does it start and stop? And notice that this really kind of goes up like that. So it doesn't really stop. So actually, we have to erase this little line here. So this actually goes on forever in the positive. So the lowest y number is down here at -4. And then it doesn't stop on the positives. So it's going to be everything from y greater than or equal to -4. Now f of 0 equaling 4. So what we do is we go to 0 on the x-axis. So here's 0. And we go up and find that curve. Here it is. And that ordered pair is over 0 up 4. So what is f of 0? So f of 0 equals 4. The next one, f of 3. What is f of 3 equal? So now we go to 3 on the x-axis. So here's 3. Then we go down and find the curve. Here's the curve. What is that ordered pair? That ordered pair is 3, comma, -4. So what is f of 3? It equals -4. All right, the next one. Is this a relation, a function? No, it touches more than one time. So this one is not a function because it fails the vertical line test. Is it discrete or continuous? It is continuous because the points do connect. The domain is where it starts and stops on the x-axis. So here's where it starts on the x at -2 and then stops at 2. So we can write it as -2, comma 2. The range where it starts on the y, here's -2 and then stops at 1. I'm just going to erase those. What is f of -2? So we go to -2 on the x-axis. So here's -2. What's that ordered pair? That ordered pair, I like to write it out here. That's -2, 0. So what's f of -2? That is 0. And then the next one, f of 0. If we go to 0, here it is, and then there's our 2 spots, and there's 2 of them, over 0, up 1, and then over 0, down 2. So there's 2 values there. So f of 0 at 1, and then f of 0 at -2. All right, the next one, this one also fails the vertical line test because it hits twice. So this is not a function. It fails the vertical line test. It is continuous because the points connect. The domain, there isn't any x values over here. It starts at 0 and goes to positive infinity. So I'm just going to erase these green lines here. Erase all this stuff here. So we say that the domain starts at 0 to infinity. The range is starting down here at negative infinity to positive infinity, or all real numbers. And then f of negative, or f of positive 4, here's positive 4 and positive 4. So those ordered pairs are 4, 2 and 4, negative 2. So f of 4 equals positive 2 and f of 4 equals negative 2. And then f of 1, here is 1 and 1. So that'll be 1, 1, and then 1, negative 1. So f of 1 equals 1, and then f of 1 equals negative 1. All right, last topic here. How do we calculate accepted inputs or domains? This first one is a graph that would be all real numbers, because it's going to be a line that looks like this. If we were to graph this out, it would have a slope of 2 and a y-intercept of 5. It's going to be a line. So the domain would just be anything. We can substitute any number in for x. The domain would be all real numbers. This would be its domain. The problem with the next one is we can't substitute any numbers in for x that's going to cause that square root to have a negative number. So we want that x plus 6 to always be a number greater than or equal to 0. So what we do is we set that radical value greater than or equal to 0 and then solve it for x. So I'm going to go ahead and then subtract 6 from both sides. So I say my domain is going to be everything greater than or equal to negative 6. What it would look like on a graph, if we were to graph this out, is it would be over negative 6 here. And this is what it would look like. If you want to say the domain as an interval, it would be negative 6 to infinity. The last one is we do not want that denominator to be 0, not 0, because that would make it undefined. So we say then x minus 7, we do not want it to be 0. So what we do is we just solve that for x. So we add 7 to both sides. So we say x cannot be 7. So it's everything but 7. So that is our domain, everything but 7. Or we can write it like this, negative infinity to 7, or 7 to positive infinity. That's a couple ways to write our domain.